So before you do anything, you want to start by looking at your domain. So when I'm looking at this one here, I see I have a square root. So that means that t plus 3, and I really don't like t because it looks like a plus sign, has to be greater than or equal to 0, which means your t value, my first domain restriction is that my values have to be greater than or equal to -3. Any questions about how I got that first one? Do you see a red light in this one? You do? Okay, so that means this cannot equal 0. So if t squared, this cannot equal 0. If you take the square root of both sides, we know t cannot equal 0. So far, I'm going to go ahead and put this on my number line. I have 0 and I have -3. I have 2 restrictions. I know that it has to be greater than or equal to -3, so I'm going to put a closed circle here. And it has to be greater than or equal to -3. But it also cannot equal 0, so I got to put an open circle here. So far I have my domain split in 2 pieces. Okay. So now let's see if we have any other restrictions we need to add. So let's take our x parameter. If x equals the square root of t plus 3, let's solve that for t. So I'm going to square both sides, which means that x squared equals t plus 3. Subtract the 3, and that's what you get. So x squared minus 3 equals t. And now you're ready to take that and substitute it into your y parameter. Any questions about how I got to here? How I solved this and got this? Okay, so now we're going to take this and put it here. Just like so. So then that will give me y equals 1 divided by t squared, and then that x squared minus 3 goes here. So that's my equation. You don't have to simplify that because simplifying it is not going to change it, so you can just leave it that way. Nothing is going to cancel out is what I mean. Sometimes when you simplify it, it can cancel out the numerator, but my numerator is just a 1. It's not going to cancel, so we can actually end that there. So this is my equation, but that gives us a whole new red light that we need to consider. So this also cannot equal 0. So let's set that off to the side because we're going to need to add that to our number line. If x squared minus 3 cannot equal 0, I'm going to add the 3. And then I'm going to take the square root. So x also cannot equal plus or minus the square root of 3. So that's 2 more restrictions that I need to add to my number line, which originally had 2 restrictions. Now I have 2 more. So in your calculator, where do you think the square root of 3 is going to fall on the number line? I mean, what do you think what is the square root of 3?
1.7.
1 point something, right? So positive and negative. So that means I need to add that here. I'm going to go ahead and zoom back in on my number line. I'm going to take this off. So I need to add negative square root of 3 here, and positive square root of 3 is going to be somewhere there. And remember, it can't equal these either. So now my domain, the complicated part about this isn't writing the equation, it's stating the domain. Because now my domain is broken into 3 pieces. So this is my first piece. This is the second piece. This is the third piece. And this is the fourth piece. just like that. All right, so I'm gonna write my domain. I don't know where I'm gonna write it at. I think I'm just gonna write it underneath. I'll just cross this out so I can write it right underneath the number line. Okay, so let's go ahead and take that number line and write it as an actual domain statement. So my domain, so the domain, oops. Get my little board together. Okay, so domain. So my first piece, I have a bracket on -3. You see how that has a closed circle. So -3 to -√3. All of these are going to have parentheses because it can't equal these three numbers. It can equal -3. That's why that has a hard bracket. Union -√3 to 0. Union 0 to √3. Union that's a union, and then it'll be √3 to infinity. So that's a pretty long domain statement. That's your domain for this question, and then this is your equation. So this is the first part of your answer, and this is the second part. Okay, so we're actually going to start working through our equations today. So in your packet, go to page 10. So the second part of chapter 10 is the word problem component. So we're only going to do 2 word problems today, and then we'll end in there. And if you need a pass to come back to do corrections for chapter 8, you can come up. I'll write you pass. But any questions about the bell work before we move on to page 10? So yesterday's recording, I just finished out page 9. It was just 2 questions at the bottom of page 9. It's a 10-minute, maybe 13-minute video. Please make sure you watch that as you prepare for your test, which is now that we know it's next Friday. Okay. All right, so let's look at this equation that we have at the top of page 10. You don't need to memorize that. This is going to be provided to you. But I want to dissect this with you. What does this x and y parameter mean? So first of all, x, you should know, whenever we talk about x is a horizontal distance. So x is your horizontal distance. So if you know how far away something is, we're going to use that to solve for t. Y is height, which is your vertical distance. Well, I don't need to write distance, so I'll just say vertical. So x is how far away something is. Y is how high something is, okay? So now let's look at both of these parameters and dissect it a little further. Notice that they both have this v sub 0. I'm going to highlight it actually. This v sub 0 that you see in both, that represents velocity. So v sub 0, that's your velocity, which will always be given to you. And then you see how they both have this theta? That is your angle. That's also going to be given to you. So they both have that. And we all know that x is your cosine. So for x, we're using cosine, and for y, we're using sine. Okay, so now let's look at your vertical component. It has 2 additional variables in it. So this next one, G represents gravity. So let's look over here. Do you see how G says there's 2 different numbers that we can use for G? Yeah. All right. If it is in feet, we're going to use this one. So if your velocity says feet per second, we're going to use that gravity. And if it's in meters, we're going to use 9.81. So, or it's either one or the other for gravity. Gravity is a vertical pull, which is why it's used in the y parameter, not the x parameter. Gravity does not play a force in horizontal distance, it's vertical distance. So you have to look at it to see if it's in meters or feet to determine which one you're going to use. And I'm going to say like 85% of the problems that we do will be in feet. Okay, so most of the time we're going to use 32.2. And then our last variable is this one here, which is at h sub 0. That h sub 0 is your initial height. So h sub 0 is your initial height. So that's the meaning behind all of these things here, of all the variables. So we're substituting everything that you see I have highlighted. There's actually going to be numbers there. So that's the meaning behind the variables.
Are you going to give us this equation?
Yes, ma'am. It will be provided to you on the test. I said that, but you probably had the earbud in, didn't hear me. It's okay. I'm used to it. Okay, guys, so let's go ahead and do number 1. Okay, so it says a ball is kicked with an initial velocity of 60 feet per second and an angle of 38. So when it's kicked, h sub 0 is 0 because your initial height is 0, is kicked. And most of the time when you kick a ball, you kick it from the ground level. So that's why our initial height is 0. The initial velocity, v sub 0. So let me go ahead and highlight. So we're going to put that 0 is going to go here when we write our equation. Our initial velocity is 60. So we're going to put that 60. That's going to go here and here. That's where the 60 is going to go. And then it also told us that our angle is 38. If I can get the 3 to work, there we go. And that angle is going to go here and here. And lastly, do you notice how it says the velocity is in feet per second? So because it's in feet per second, this is the gravity that I'm going to use. I'm using this 32.2. I'm not going to use this 9.81 in this question. I'm only using 32.2. All right, so now that we have that, let's go ahead and do part A. So for part A, it says write your parametric equation. So we're going to do that, and we're simply substituting in those numbers. So x of t, so it's going to equal, I'm going to put my parentheses, and it's going to equal the initial velocity, which, what is my initial velocity? 60. So it's 60 cosine, and then what is the angle? What is theta? 38, and then t. That's your horizontal parameter. That's my equation. So now let's write our vertical parameter, y of t. Okay, so right here, do you notice how it says negative 0.5 times g? Pick up your calculator and figure out what is negative 0.5 times 32.2. So I like to just figure out what that number is. So we're going to take negative 0.5 times the gravity, and we're using 32.2 because this is in feet. So negative 0.5 times 32.2 should give you negative 16.1. And then I have my t squared plus, and then I'm going to make my parentheses. I have 60 sine 38 t. Now, whenever my initial height is 0, I don't put the plus 0 at the end. Now, you can, though. I'm not saying it's wrong. If you want to put that plus 0, you can. But if my initial height is 0, I just leave it off. So you can also do the same. So that is my answer to part A. Part A, you're just substituting in numbers. That's all you have to do. You just need to understand the equation though, so you can substitute in the numbers. So part B, it says, find the time at which the ball will return to the ground. So let's look at part B. So part B, so I'm just gonna draw a motion here. So if you kick the ball, so this is my ball, it kicks, and then eventually it comes back to the ground. The one thing I know about, if it's on the ground, the vertical distance is 0. I don't know how far away the ball traveled, but I do know if it's on the ground, anything on the ground has a vertical distance of 0. Does that make sense? Any questions? So that means that because it's on the ground, I'm gonna write vertical distance 0, that I can use the y parameter to solve for t. So I'm actually going to, because I can't use the horizontal parameter because I don't know the distance the ball traveled horizontally. But I can figure out t by using my vertical parameter. So if it's on the ground, that means that this equals 0. So 0 equals, and I'm going to go ahead and write this equation, negative 16.1 t squared plus 60 sine 38 t. So in order to solve this, we're going to take out our GCF because we can't factor this down, but we can factor it taking out our GCF. What is my GCF? What do they both have that I can take out?
T.
A t. Yep. So let's take out the t. Okay, so see how we have two different equations? This first one here, this represents when I kicked it. So this here, when I kicked it, that's t sub 0. And we're trying to figure out how much time it took. What's my second time? Because the ball is on the ground twice. It's on the ground when you kick it and then when it comes back to the ground. So this is the first time it hits the ground. So we need to solve this to figure out how long it takes for it to hit the ground a second time. So I want you to take this parentheses here, and we're going to set that equal to 0 and solve it for t. So that would be negative 16.1 t plus 60 sine 38 equals 0. So I'm going to subtract, because this is a number. So I'm subtracting this number, which is going to give me negative 16.1 t, and that's going to equal negative 60 sine 38. And then I'm going to divide both sides by negative 16.1. So T2 is going to be whatever you get when you type that in your calculator. So go ahead, type that. I'm not going to rewrite it. But pick up your calculators. And I just need you to type this in. Everything we do, I'm going to say this one time, and please remember it, is to the thousandths place. Give me 3 numbers after the decimal. So go ahead, type this in your calculator. And then find the t value to the thousandths place. So who got 2.294? So that would be your answer to part B. Because part B says, find the time at which the ball will return to the ground. So I kicked it, and then the time that it's going to take for it to hit the ground is about 2.294 seconds.
Is it always going to be seconds? Or is that really?
I think most of the time it is in seconds. I can't think of any example where it would not be. Yeah, it is, because see how velocity is in feet per second. So yeah. All right, last part C. It says find the horizontal distance that the ball traveled. So now that I know how much time it took for the ball to hit the ground, I could actually take this 2.294 and put it in my X parameter, because remember, X is horizontal. So let's, in our calculator, X is going to equal, it's going to be 60 cosine 38, and you're going to multiply that by 2.294. Again, to the thousandths place. Go ahead, type that in. And that would be your horizontal distance to the thousandths place. And when I did this, which I did it a long time ago, so make sure that these are the correct numbers, that is what I got. I got 108.462 feet. Go ahead and verify it though. Type it in your calculator. Make sure.
6.966.
Uh-oh.
That might have took it.
Okay. So 60 cosine 38 parentheses. Okay, did you put the 38 and the 2.294 together? Make sure you put that 2.294 in its own parentheses, because that could make a difference. Raise your hand if you got that answer. Any questions about how we work through this first one? And we're going to talk about these equations again tomorrow also, so. Okay. All right, let's look at number 2 and then we'll end there. So again, we have Beth. She's kicking a ball. Okay, so that means the initial height is 0. So as I'm reading it, I try to write down some of the stuff that I see. So she kicked the ball, so my initial height is 0. H is 0. I know that the goal is 60 feet away, so that's really good because now I know how far the ball traveled horizontally. She kicked it at a velocity of 50, so velocity is 50, and the angle theta is 30. So we're ready to type this stuff in. So for part A, we're going to write our equation first. So x sub t, so our initial velocity is 50 cosine 30 t. So I'm going to pause right there. Does everyone see how I got that equation? I substituted in velocity and the angle. That's all. The x parameter just has 2, velocity and angle. For my y parameter, which is the vertical distance, again, this is in feet per second. So I am not using this one. You can cross this one out. I'm using 32.2. So if you take that 32.2 and multiply it by negative 0.5, again, you're going to get negative 16.1. And it's t squared plus, and it's 50 sine 30 t. And then my initial height is 0. So again, I don't put the plus 0 whenever my initial height is 0. So it's important that you're able to at least write these equations. The difference between this one and the last one is that in soccer, we don't necessarily want it to hit, we want it to hit the goal. But we know how far away she is from the goal. So what's the horizontal distance that she is from the goal? 60 feet. So we know that horizontal distance, so we can use the x parameter to solve for t. So I'm going to take that parameter, my x parameter, go ahead, put a 60 in. Set it equal to 50 cosine 30 t. And now I'm going to divide both sides. because this is a number. We got to keep in mind, this is a number. So I'm simply dividing 60 by 50 cosine 30. Because that says, how many seconds will it take for it to reach the goal? So I'm trying to figure out how many seconds. And because I know the horizontal distance of the goal is 60, that's why I'm using the x parameter. So in your calculator, go ahead and type in 60 divided by 50 cosine 30. And that's going to be your answer to part A. To the thousandths place, 3 numbers after the decimal, please. So you're going to take 60 and divide it by 50 cosine 30. So who got 1.386 seconds? Okay. So that would be your answer to part A. So now let's look at part B. It says at the time that it meets the goal, what's the height? So height is what parameter, x or y? Y. So you're going to take that number that we got for part A, we're going to put that into t for our y parameter. So y equals, let me move this down a little bit because that looks like it's, so this is part A. So now I'm starting part B. So y equals, and I have negative 16.1 t squared plus 50 sine 30 t. And we're going to put that 1.386 in. So you want to type it in just like this. And that would be your answer to part B. Let me go ahead and move that up so everybody can see. All right, who got 3.722? I'll give you all a minute to type it in. So you want to make sure you're typing it in and you're actually getting the answer, because you have to square this first one. Remember, this first one is squared. So your vertical distance is 3.722 feet. Okay, so did she make the goal? How high is the goal in soccer? 5 feet. So did she make it? If it had a vertical distance, so this is where you got to know soccer, I guess. So the net is like this, right? And the ball, when it hit it like about here. Is that okay in soccer, or is it supposed to go over the net? She made the goal, right? Because as long as the vertical height is less than 5, then she's going to make the goal. If it's over 5, it's going to go over the goalie. We don't want it to go over. We want it to be under. So the answer to part C is yes. And it's because the height was less than 5. Okay, so we're going to end there. If you need a pass to come back later today, see me. Use this last 10 minutes to keep working on homework 16. Remember, it is worth 100 points. So.